Hi, everyone. I'm an adjunct research fellow and PhD candidate at the University of Southern Queensland, but am based in Minnesota in the US as I am able to do much of my work remotely. Today, I'm speaking to you from Minnesota on the traditional and treaty land of the Dakota people who, along with the Ojibwe, are the indigenous people of this land, Minnesota Makoche, Dakota for the land where the water reflects the sky. I have an interdisciplinary background involving environmental sciences and humanities, as well as scientific and cultural aspects of astronomy. My research focuses on the effects of human activities on both Earth and space environments and delves into the complex relationships that humans have with both the skies above and the land below. I've been a member of the American Astronomical Society's Committee for the Protection of Astronomy in the Space Environment, COMPAS, for several years, and I also co-lead the Community Engagement Hub of the IAU's Center for the Protection of the Dark and Quiet Sky from Satellite Constellation Interference, which is thankfully abbreviated IAU-CPS. My involvement with these and other organizations has led me deep into the always fascinating, often frustrating, and sometimes frightening world of the intersection of dark skies, astronomy, and the rapidly growing space sector. There are many ways in which exponentially increasing numbers of satellites, as well as other emerging space activities, stand to affect the night sky, as well as the Earth and space environments. To begin with, there's the issue of the rapidly growing number of objects in orbit. On the left, you can see the rapid increase in the numbers of satellites launched in recent years. Before the launch of the first Starlinks in 2019, there were just over 2,000 functional satellites in orbit. Currently, this figure exceeds 12,000, of which close to 8,000 are Starlinks. On the lower right-hand side is a graph showing the numbers of Starlinks re-entering Earth's atmosphere on a monthly basis in the past few years. As the Starlink satellites are designed to each last about 5 years, as they build out more of their constellations, the number of re-entries will continue to increase. The increasing numbers of satellites have a variety of consequences. They reflect sunlight, so they are often visible in the night sky, particularly during twilight hours. In terms of professional research astronomy, increasing satellites can have detrimental effects. Some of the areas of astronomy that are particularly apt to be affected include research that requires long exposure times on large areas of sky, research on faint distant galaxies, exoplanet transits and wide field surveys, and near Earth object research. Also, unpredictable transient phenomena such as gamma ray bursts may go undetected if a satellite traverses through that part of the sky at an inopportune time. But of course, it is not only professional astronomers who are affected by the appearance of growing number of satellites in the night sky. Anyone who looks at the night sky with the unaided eye for cultural, religious, navigational, or any other reason will notice far more satellites making their way across the sky than was the case even a few years ago. In addition to the matter of the appearance of the night sky, there is the issue of orbital crowding and debris. There are tens of thousands of pieces of trackable debris in orbit, and it is estimated that there are millions of pieces of smaller, untrackable debris. With a growing number of operators and increasing numbers of satellites, the more densely populated orbits, evasive maneuvers to avoid close approaches are becoming more common. There are concerns that if there were major collisions in orbit, the debris created in such impacts could lead to a cascading series of collisions, aka Kessler syndrome, which could render orbits unusable and dangerous to traverse through for long periods of time. Obviously, leaving satellites up in orbit after their useful life is over is a bad idea in this context. So having satellites re-enter and burn up in the Earth's atmosphere at the end of life is seen by many satellite operators as the responsible thing to do, as that means fewer dead satellites cluttering up orbits. However, satellites re-entering en masse is changing the composition of the upper atmosphere, and given the growing quantity of satellites that are slated for re-entry in the coming decades, it is questionable whether continuing to use Earth's atmosphere as a garbage disposal is an environmentally benign practice. If re-entering satellites and other space hardware do not fully burn up in the atmosphere upon re-entry, other problems can occur. While no one has yet been killed by an incoming piece of human-created space debris, the odds of property damage and perhaps casualties at some point, while still low, are growing as the number of incoming objects increase. And the practice of sending re-entering space debris into the Pacific Ocean so as to avoid more densely populated areas raises another set of social and environmental questions. So what has been done so far to address these issues? And has any progress been made in finding solutions? Not long after Starlink launches commenced, members of the astronomical community began to engage in conversations with SpaceX about their concerns. SpaceX tried a number of different ways to make their satellites dimmer. There was DarkSat, in which they essentially made the satellites darker, but that ended up resulting in overheating the electronics, so that had to be abandoned. There was VisorSat, but this ended up causing issues for satellite transmissions, so it was also scrapped. Currently, SpaceX is utilizing a film on their satellites, which they also sell at cost to their operators, which essentially bounces off the light at a different angle, so the satellites appear less bright from Earth. They have also made changes to the orientation of satellites at various stages of their orbit raising in an effort to reduce reflected light coming back towards Earth. While these efforts have resulted in definite decreases in the optical brightness of satellites, they still have yet to achieve astronomers' stated goals of 7th magnitude, which would be invisible to the unaided eye. In the U.S., there are coordination agreements between large satellite constellation operators and the National Science Foundation, or NSF. As part of these agreements, operators engage with NSF on the matter of reducing their satellites' effects on optical, infrared, and radio astronomy. On a more international level, the 4 hubs of IAU-CPS continue to engage with this issue in a variety of ways. The Industry and Technology Hub continues to work to engage satellite operators in conversations on this issue and are hoping to engage with more manufacturers in the coming years, as it is much easier and less expensive to incorporate dark sky considerations at the earliest stages of design. Meanwhile, the Policy Hub has worked to provide recommendations of elements of policy that could be incorporated into national and international frameworks to address dark and quiet sky issues. They have also been involved in efforts to raise awareness and develop best practices related to these matters at the United Nations Committee on the Peaceful Uses of Outer Space, UN COPUOS, where there is currently a 5-year agenda item focused on dark and quiet skies. SatHub's mission is to, quote, bring together the astronomical and wider community to increase and disseminate scientific understanding of the impacts of satellite constellations on astronomy, identify ways they can be mitigated, and publicly share expertise and tools that enable this, end of quote. They have conducted observation campaigns with amateur and professional astronomers focused on obtaining data on the brightness of various satellites and created an online repository where observers can share their data. These 3 hubs are generally focused on interactions and activities involving satellite operators and professional astronomers. In contrast, the Community Engagement Hub, which I co-lead, is tasked with engaging with everyone else who stands to be affected by the changing night skies as a result of satellite constellations. Our initial aim was to find ways in which broader communities could be more engaged with these matters and to provide avenues for their perspectives to better inform decision-making processes. For a whole host of reasons, this has proved extremely challenging to accomplish in practice. Our hub has also been focusing on creating educational materials to help the non-specialists learn more about issues relating to satellite constellations and the night sky. And beyond CPS, a variety of national and regional organizations, such as the American Astronomical Society and the Royal Astronomical Society, among others, have been highly involved in initiatives aimed at reducing the effects of satellites on the night sky. Thus, current efforts have resulted in some promising paths forward. However, the pace of launches continues to increase, and it is worth noting that, broadly speaking, the dialogue between astronomers and satellite operators, as well as industry efforts to reduce satellite impacts on the night sky, are purely voluntary. Another thing to consider is that even if, via creative engineering and operations, satellites can be made less bright than they currently are, there's still the issue of the sheer quantity of them being launched, orbiting, and re-entering. There are some things that might come to mind as possible solutions to these concerns. For one, what about the notion of launching fewer satellites? Generally speaking, that is a rather unpopular proposition among industry circles. For one, that notion often finds itself in conflict with the widespread narrative of the need for rapidly increasing economic growth in space. Rapid expansion of commercial activity into space is seen as essential for continued innovation, and there is also the aspect of states trying to win the race of having the most influence in the emerging space economy. In this climate, increased regulatory burdens are seen to be an impediment that could stifle the pace of growth. In response to the notion of increasing regulation, satellite operators are often quick to point out that they could always just move their operations to a country that has fewer regulations. When I ask about the issues of orbital crowding at space industry related events, I keep getting similar responses. Increasing space situational awareness, the ability to know where satellites are in orbit and where they are going, as well as the practice of evasive maneuvers, will keep raising the density at which orbits can be filled, I am told. When I inquire about the ability to safely maintain increasing orbital densities in context of inevitable hardware malfunctions, space weather events, collisions with untrackable pieces of small debris, and even more concerning, possible ramifications of bad actors or states engaging in kinetic or cyber warfare in orbit, I always hear some version of, but improved technology and better engineering will solve this problem. In recent years, the concept of space sustainability has become a buzzword in and around the space sector. While in many respects such initiatives are laudable and may help to address debris issues, for example, it often appears that the end goal of space sustainability is to devise ways that space can be put to maximal use in service of humans and to ascertain how we can best exploit space and its resources as extensively as possible for as long as possible. For example, when searching online for images illustrating lunar sustainability, here's one of the things I found, a diagram of factors affecting the sustainability of the lunar economy. Here we can follow the arrows, seeing how colonists are sent to the moon, while meanwhile the raw materials and resources are extracted from the moon to be used elsewhere. The lunar resources fuel the development of further colonies, and more resources are extracted from the asteroids and beyond to fuel further exploration and exploitation. Such narratives of colonizing and exploiting the moon and beyond clearly borrows heavily from the highly problematic legacy of colonialism on Earth. Often connected to quote unquote sustainability are emerging space technologies that could be used to harness solar energy in space. This could be in the form of gigantic solar panels in orbit, which could then beam the energy harnessed down to Earth as microwaves, or in the form of huge reflectors, which could send sunlight to illuminate terrestrial solar panels or provide sunlight for late night events, whichever the paying customers might request. I will not elaborate on the ramifications of such endeavors could have on the night sky, the nighttime environment, or on humans who do not wish to be adversely affected. I'm sure you can imagine. So where do we go from here? I would argue that the continual pursuit of more and better technology as the linchpin key to solving dark and quiet skies and space sustainability matters more broadly is problematic. Pursuing technological fixes alone can result in band-aid type solutions that, while seemingly helping to solve problems, also end up drawing attention away from the deeper causes that created the problems in the first place. While issues like orbital debris and changes to the night sky brought about by numerous satellites may seem to be relatively novel issues, I would suggest that they are merely new symptoms of a pre-existing condition. Perhaps we all ought to ask ourselves, what is the nature of our relationships, not only with each other as humans, but also with the Earth, the night sky, and the larger space environment? When we see all that is around us as primarily tools of instrumental value rather than entities to which we owe some degree of respect and consideration, this inevitably leads to a way of being in the world that creates much suffering. Unintentional or not, in many circles, exploitative colonial narratives are often glorified as the only way forward for humanity in space. True, there are many who have more nuanced perspectives and those who have vastly differing visions for how humanity ought to conduct itself in space and elsewhere. But these voices are often drowned out by the relentless drive to expand the space sector at breakneck speed. Oftentimes, attempts at raising attention to these deeper matters fall on deaf ears. Even when those listening have the best of intentions to hear, it can be very challenging, as such ways of thinking are often seen as foreign and incomprehensible. There are many brilliant engineers and other specialists working in this space who have not had the benefit of extensive exposure to the humanities or other ways of knowing, and thus they often approach every problem as nothing more than an exciting and complex engineering or technological challenge. Thus, there is a dire need for not only more venues for interdisciplinary research activities aimed at addressing the emerging challenges affecting the night sky, the Earth space environment, and humanity, but also collaborations that emphasize transdisciplinary approaches. Cultural astronomy is a relatively interdisciplinary field, but a lot of the space sciences are not. There is the long-standing problem of this disrespect and disregard that many trained in science or engineering have for the humanities and any other approaches they deem to be other and thus inferior to science. This needs to change as approaches from all academic disciplines and diverse cultural teachings are needed if we are to work together to create a future which even resembles something that is humane and respectful to all. As this poster shows, science can tell you how to clone a T-Rex. However, humanities can tell you why this might be a bad idea. Thank you for your attention, and I look forward to working with you all on these timely issues.